So the meeting has been streamed. So
Monica, if you share host so that I can share my slide.
I'm doing that right now.
Okay, sir. Okay.
I already set recording for you now.
Okay. About recording, you should record as a cloud. You need about here, but I can initiate it. Cloud.
Okay, let me stop it. You stop it and record it. Stop it and record it.
Okay. So good morning, everyone. Today's class basically will entail studying the Newton's laws of motion. And when we discuss about the Newton's laws of motion, it is not something that is actually strange to us. It's something we've learned during our O levels, and this is just a refresher course for all of us. We'll go over it, and basically, after Newton's laws of motion, we'll study linear momentum and impulse. So after which, the class we'll have on Thursday will basically be to solve questions. So that is basically what we will do for today. So today, I hope you can all view the slide. So now we have the Newton's laws of motion. And under that, we will be studying forces, because it is the force itself that actually made up the laws of motion that we will be studying. Now, the laws of motion, which were actually established by Isaac Newton, can be divided into three. We have the first law, we have the second law, and we as well have the third law of motion. And thereafter, we relate these to what we refer to as weight and what we refer to as the mass. And thereafter, we'll see some problems. Just like I said, the problems will be solved during the problem will be solved during the next class, which is Thursday. If you are just joining, please mute yourselves. If you are just joining, mute yourselves. If you are just joining, please mute yourself so that you don't disturb the class. So just like I said, these are the preambles of what will be taught. So from here now, we will then move on to discuss the first aspect, which is the force. What is a force? A force is a push or pull. A force, please mute yourselves as soon as you join. Please mute yourselves and stop disturbing. The force is a push or pull. If you are opening a door, either the door, the person raising the hand, what do you want to say?
Sir, please, will we get the slides?
Just don't worry. Don't be after the slide. Be after the teaching there, you can ask your questions. Please. So the needful will be done. Don't worry. The needful will be done. It's been recorded, and the recordings will be shared with you. So when you push or you pull, you are actually exerting a force. And when you exert a force could be exerted on an object that is at rest, or an object that is in motion. When you apply a force to an object in motion, definitely, one, you'll be changing so many things about the motion of that object. It is either it changes the direction of the object, it alters the acceleration of the object, or it actually stops that object. These are the three possibilities that can occur when you exert a force on an object. It either changes the direction of motion of the object, it either stops the object from moving, or an object already at rest can be placed in motion. So these are the three things that you can observe when you exert a force on an object. When you exert a force on an object, those are the things that you can observe when that is done. Now, the magnitude of the force you are applying now, the magnitude of the force you are applying can be measured using the spring balance. Because ordinarily, if you have a footballer playing football on the football field, he only kicks the ball. The magnitude of the force he has applied is something we cannot measure. But if you have instrument, for example, now, if you are pulling an object and you have attached a spring balance, just like you see under here, the box of the olive oil is being pulled. So because of the spring balance, we can definitely measure the force we are applying to pull the box of the olive oil. So the magnitude of the force can only be determined when we actually attached a measuring instrument like the spring balance. Now, we then move on to the Newton's first law. We have been able to establish earlier that for motion to exist, there must be a force exerted. It could be a push or it could be a pull. Now, this now leads us to the first law of motion.
Yes,
It
yeah,
leads
just
us to the first law of motion. So the first law of motion, which is also referred to as the law of inertia. Mesoma, what do you want?
So please, can you tell them to stop sending messages on the chat box? If we are not seeing the screen properly because of the messages.
Because of the message, please,
You can,
those of
you
you
Yes,
can
sending
mute
messages, please stop.
notifications. You can mute notifications.
Please stop sending messages. After the class or at interval, I will always stop for you to ask your questions. Also, after the class, the recording will be made available to you so that you can play back and see what has been taught today. I hope it is clear. Stop sending messages, please. And mute yourselves. If you have questions, just raise your hand by clicking the button. I will always respond. Please, mute yourselves. So now, let me mute off. I can see hear some noise from the background. Okay. So the Newton's first law, which can also be referred to as the law of inertia, So every object, it states that every object continues in a state of rest. It continues in a state of rest or with uniform motion or uniform velocity in a straight line, as long as no net force acts on it. And you can see the example of this book that I have here now. The book I have here, you will observe that the book here is moving on the straight line, being pulled by this hand in this direction. It is being pulled by the hand in this direction. So it will continue on that straight line on the table this way, unless a force acts on it. If a force comes and strikes it from, so maybe this way. If you have a force coming from above and hits it, definitely the force will definitely change the direction or change its velocity. It will change the direction or it will change the velocity. That is what the force is going to do to this. So for every object, it will, and when it moves with uniform motion, that means the acceleration is not changing. That means the acceleration is not changing. But the moment a force acts on it, then the acceleration changes. The moment a force acts on it, then the acceleration changes. For example, if I have a ball
I'm not saying
Sir, we
that
can't
you
hear
are the
you.
one that I
Sorry,
have to
sir, we
take
can't hear you.
about 12.
Sir, we can't hear you.
Can't hear you, sir. We can't hear you. I even thought it was my network.
He's not talking.
He's logged out.
He has
Oh,
left. He has logged out.
oh my God.
Not the one that did.
Someone